Hey there, this is my submission for the Michaelis Menden equation derivation. I apologize for kind of repeating myself, as I'm going to be probably starting and stopping, as it's kind of hard to both write and film at the same time. So without further ado, here we go. So the first portion that kind of start off with is the kind of main idea. And we'll kind of go through this as we go. So I'm trying to keep this paper straight as best I can. So, as we've kind of learned in reading, is this is the overall idea of an enzyme substrate kind of process. So E representing the enzyme as substrate, and there is actually a natural tendency to not form the enzyme substrate. Actually, another term here. Process. So actually, there's a lot of times where before ever reaching the enzyme substrate kind of transition point, actually go backwards. But every so often, we do continue on in forming the kind of intermediate step here, and then ultimately forming the enzyme substrate product. So another main idea that we also kind of need to keep track of, that actually we're going to kind of reference later, is this. Sorry, I'm waiting for this to kind of come in focus, and it's working on it here. There we go. So, this main idea, is basically, it's going to reference actually the P, the product, which we're going to get to later. So, because again, the ES product and the K2 ultimately going to lead to the product, but we first need to kind of further break down the enzyme substrate kind of intermediate there. So to break down, the next number of steps are going to break down the ES here, and we're going to get there eventually. So the first is this. And kind of as we go along, you're just some of these steps is just going to be kind of old-fashioned stoichiometry, where terms start canceling each other out, and we kind of clean up some of these equations as we kind of go. Okay, so what this kind of line here is referring to, again, is all for ES. So again, these next few steps is all about breaking down this right here. And so when you start looking, you start seeing some familiar terms. you see K1, you see K minus 1, and K2, which all appear here. So what we're accounting for are all the things that both lead to ES and take away from ES. And if you kind of look, both K1 going back to the enzyme and substrate, and ultimately the enzyme and product, both actually take away from the ES. There's less of this here. So let's, what we're going to do next, this is assumption that we're going to make here. Before we move on to the next step, we're going to assume that K minus 1 is greater than K2. So the reason we're assuming this is that actually what occurs more often is that the enzyme substrate product is it's the more natural tendency is not to get to this point. So that's why this is greater than K2. So we get to another this kind of way to kind of say this, and D is actually stands for delta. So I don't know if you know that before, but it's just basically means change. So it's going to be the D or delta of ES over time. And what this kind of boils down to is that the concentration of ES is not changing over time. All right, now so this is kind of rearranging the formula that we did up here. So if we rearrange, remember this, we said here is 0. So if we rearrange this portion here, we end up with this. This is just cleaning up the work that we've already kind of done. Equals. Okay, so we see that that's just, again, kind of a cleaned up version of that equation. So next let's solve for ES. So that would bring us here. And then kind of what happens next is that Michaelis Menden wanted to define a constant for these kind of numbers here. So now we're going to come up with a new term. So we then have this. Sorry, my handwriting's getting sloppy there. So if we go back and look, this equation here is a bit of an inverse of this. So we have our next step. Equals, not plus, equals. So the next thing we want to do is get rid of E. So we're going to make another equation here. So the enzyme total, T for total. Sorry, now it's running together. Equals E plus ES. So this equation makes sense because if the enzyme total, we would add up the enzyme substrate complex plus any sort of other leftover enzymes. So we're going to now rearrange this and solve for E. So then we have E equals enzyme total, enzyme substrate. And then I'm going to plug this into the previous equation up top here. This number 9 right here is what we're going to plug that into. So this is 12. So we end up with ES equals enzyme total minus E enzyme substrate again, and this is all over Km. So now if we take these terms here and we plug it into actually one of the original equations up here, we then end up with something a bit more familiar, which is this. Sorry, I'm trying to hold on to paper and also write. So the next step that we want to do is we want to eventually get to Vmax, and the way to do that is to kind of max out the substrate. Actually I forgot a term here, so this is plus there, Km plus S. So the way we're going to do that is if we max out the substrate, actually this Km becomes so small that it is kind of now negligible. Because if let's say a substrate was a million, whatever its value is plus a million isn't noticeable versus this being multiplied by S. Then we get a new term for V max. So this is 14, which is S 2 enzyme total over Km. Now, if we were to go back here, actually this would cross out. So substrate over each other is going to cancel. As we said, the Km is actually infinitely small. So actually what we really end up with is Vmax equals K2 ET. And now let's go ahead and substitute this term over number 13. And we end up with this V equals V max substrate over K. Hold on, I'll refocus here in a minute. that's Km, that's a plus S. This is also substrate. Right, so now we need to find what half of Vmax is. So half of Vmax. And so if we plug this in, half Vmax, I'll refocus here in a minute. We end up with this. So this is a little bit of algebra. So if we cancel out Vmax on both sides, end up with this. Half equals S over Km plus S. End up with that. Again, we're just canceling out terms at this point. Then if we cross multiply here, we end up with this 2S equals Km plus S. We're now subtracting S from both sides. So we get S equals Km. So again, we subtracted S from both sides. So we got S, it's Km. So ultimately, this tells us that when S equals Km, V max. So ultimately, this tells us that when S equals Km, V equals half of, that is V max.